For this video, we're going to take a look at how to solve an inequality looking at a table. This inequality wants to know when y1 is less than y2, and the information we're given is what we see here in the table. To solve using a table, you want to glance down your columns for y1 and y2, and first just try to find where the two are exactly the same. Notice right here when your x is 3, the y1 and the y2 are both -1. This is where they match, where they're actually equal to each other. We do not want when they are equal. If we did, we would say the answer would be 3. And our solution set would just be 3 if we wanted when they were equal. The statement up here asks for when y1 is less than y2. So we find where they are equal, and then we examine what happens just before and just after to find out if the y1, this is this column here, is smaller before this spot where they're equal or after the spot where they're equal. Looking at this next item here, that is smaller than where x is 3 and they are equal, notice that this value right here, -1.167, is actually larger than -2.5. So the values, if you continue to compare them going this direction, the y1 is actually greater than the y2, which means if we want when y1 is less than y2, we do not actually want that section of our values. Compare right after the spot where they're equal. Notice this is -0.833 and the y2 is 0.5. 0.5 is larger than this, so that means that the y2 is bigger and the y1s are smaller. And notice if you compare going down here and continuing to the where the x values are larger than 3, it continues to be the same thing. So that means that from 3 forward, but not including 3 because this symbol does not have a line underneath it, all the values are larger on y2 and smaller on y1. This section here, going from here downward, which in this case is actually where the x values are greater than 3, is the section that we want. But notice that this symbol here does not have a line under it. So if you use integral notation, we're actually going to use a round bracket here at 3 and continue with all the values that are larger than 3, since that's what we have as our x-coordinates here on our table as we go down the table. Integral notation, that means that the smallest item you will have is 3, and we don't include that, so it's a round bracket. Then you put a comma, and notice that in this case, it's implied from this table that it's everything larger often towards infinity. So we use infinity for our second item, and since we never reach infinity, we use a round bracket. In set notation, these would be the values where x is greater than 3. So you write that statement, use a straight line for such that, and then put an x and surround everything with your set bracket. This is read the set of all x such that x is greater than 3. Which in the table, that's what's displayed here as the values where the y1 column here is smaller than the y2 column, which is what your statement wanted.